I'm going to walk you through the steps I did to replace the heating elements in my hot water heater. I've done it multiple times before, but this time was a little bit more time consuming and difficult than previous. So I tried to capture everything in this video because I believe that details matter when it comes time to trying to help someone out doing it for the first time. If you don't want to watch the entire thing all the way through, I have broken it up into chapters. You can click on the chapter in the bottom left corner of your screen and skip ahead to the parts that you wish to watch. I hope you find this useful and enjoy. So I'm having an issue of no hot water, which has happened before in the past, so I'm pretty sure I know what the issue is. Um, Checking the breaker here, you can see that the breaker has not been tripped for the water heater. So we're going to go ahead and turn it off so we can do some testing. First, I'm going to take the top cover off here. This water heater has two elements in it. It's got a top heating element and a bottom. This is an electric unit. So I believe at least one, if not both of the elements have burn up, which tends to happen about every year or so, just because my water is so hard. A lot of calcium and iron and stuff in the water, and it builds up on the elements and causes them to blow out. It just pulls out, and there's a little lip in the bottom that you'll lift up on. You can see that goes down inside of there. It just has the one screw that holds it at the top. Take this insulation and lift it up. You can see underneath here, and again, we've already turned the power off because there's some open terminals in here that you could get electrocuted by. There is a cover that's just really clipped onto the top. You kind of unsnap it off the top here. You can see here is where you can set the temperature of your water. Do you want it to be hotter or not so hot? You can adjust it here with a flathead screwdriver. And then this is a reset button for this safety breaker. Um, you can hear that click when I pushed it. So something tripped to click that off. So I'll put it back together, turn the breaker back on. You could hear the sound of it running, and then about 1 to 2 minutes, it trips the breaker. So there's definitely an issue with probably one of the heating elements. So what I'm going to do now is I'm going to drain the hot water tank. I will shut off the water supply on top going into the tank, and then I will connect a garden hose here, run it outside, and then we'll turn this valve 90 degrees and drain the water out so the water level goes down below where these elements are, and then we can remove them and check them. All right, I have the hose connected here. First, I'm going to turn off the water supply going into the hot water tank, and then I will open this valve, just turn it 90 degrees, and I could hear the water gush there for a second. It should be coming out of that hose. We'll go outside and check it here in a minute, and once it gets just a little bit, we'll come back and we'll crack that plug in the top to relieve some pressure so we can pull air and drain better. I have a long-handled sort of breaker bar, 1/2 inch drive, which fits right in that plug. So we'll go ahead and put it in there and then loosen it up just a little bit, crack it loose. Sometimes it's tight because it has a lot of pressure on it.
once I get it up out of here, you can hear the air pressure that's built up inside of here. I'm going to open it up real slow because it does have some pressure behind it. All right, that's it. And the water should be draining out of the bottom into the hose. We'll go outside and verify that. All right, here you can see the water coming out of the end of the hose. And you can also see all the calcium deposits. See those white crystals? Or not crystals, but just buildup. All of that's coming out of my hot water tank. That's the lovely hard well water we have here. That calcium buildup is a whole lot worse inside of the bottom of the tank and on those elements. You'll see once I get them removed. So what I'm going to do now is I have already turned off the power, turned off the breaker, drained the hot water heater. It's completely empty. There's no power going to it. I'm going to test both of these elements. I'm going to do a continuity test and then a resistance test to see what they're looking like. So I'm going to first do it with the power wires connected to them, and then I'm going to disconnect the power wires and see if there's any type of continuity or resistance difference. So first we'll do continuity. You can hear the beep sound. It means we have continuity. So for the top one, that one has continuity all the way through. For the bottom, same thing, continuity. Now we'll go to that was a continuity test. We'll go over here to ohms to test the resistance. I just put it on 200 because I don't think it's going to be that that much. So for the bottom one, let's see what we can get. Looks like about 13.7 ohms. For the top one, 13, 12.9, 13. So there's a little bit difference. Now I'm going to remove the power wires and try these tests again to see if that has anything to do with it. Okay, and it's just like any other type of electrical wire. You just back the screw out. Don't need to take it all the way out. And the wire is just hooked around it there. So we will remove the wire from the top element. That one pulled the screw out with it. That's okay. We just stick it back in there. And same thing for the bottom. Just pull the wires out. Now we're going to try our continuity test again. For the top one, we do have continuity. For the bottom, same thing, continuity. Now let's check the resistance on these, see if we get the same result. So for the bottom one, 13.7, that's the same. For the top, 13, 12.9, that's the same. All right, so now we know that it does not matter whether the power wires are connected to the elements or not whenever you test them for continuity and resistance. I know something's going on here. Yesterday, this top little breaker built in was tripped. So I reset that, turned the power back on, and then my main breaker in the fuse panel tripped, and it did that twice. So I know something's shorting out, and I believe it's one of these elements. So we're going to go ahead and remove this top one first. So you can potentially remove these with a pair of channel locks or something, although it's a little difficult getting a good grasp on there and pulling that stuff out. However, um, they do make wrenches for these elements. So this here is a filter wrench. I'll link it in the description below. And essentially, it just goes over the element like that. And then you take a screwdriver, stick it through the holes, and you just turn it with a screwdriver. It's going to be kind of tough at first if they've been in there a while, or if your water's hard like mine, kind of seizes them up. All right, so here's the part. This here is the heating element. You can see the calcium buildup on this thing, different places. Kind of flakes off. That's what you saw coming out of the end of the hose out there. Um, this element looks like it's in decent shape. It's not busted or anything. We'll kind of pop this one back in here, and we'll take a look at the bottom one. I've done this multiple times, and it's never been this difficult trying to remove this lower element. I beat and beat on this thing with that wrench and hammer for over an hour, and it wasn't budging until I was able to go to the store and get this socket right here, this 38 millimeter socket, to get a better grip on that element, along with my half-inch drive breaker bar. I put it on here, and it was like butter, just come right open. So, word of advice, don't waste your time with that silly element wrench. Go ahead and get you a 38 millimeter socket before you get started. So what I'm trying to do now is remove this old element, which I know is busted, which is not allowing me to pull it out. I had a difficult time trying to remove this lower element, so I've sped up the footage so you could at least see what I was dealing with and the trouble it was giving me. All I could do was twist and pull and bend on this element. Obviously, I knew it was garbage, so I wasn't worried about damaging it in any way. But I had to just bend it back and forth with channel locks and um, uh, pry it out the best I could until it finally came the rest of the way out. Oh my gosh. There it is. Here's the piece after I finally got it out. And you can see on the edge near the bend there, you can see looks like a coil spring or a wire coming out of it. This right here. This is the inside of the filament that busted. So this is why it was tripping and going bad. But it apparently was still making enough contacts to where it passed the continuity test. But you can see there how it's split open. So this element is toast. Now the fun part is try to get as much of that calcium out of the bottom of the tank as possible before reinstalling the new element. All right, I have the new heating element here. Same voltage and wattage as what come out, 240 volt, 4500 watt. Link will be in the description to these parts. So I'm going to go ahead, after hours of trying to vacuum out some of the calcium buildup and stuff down in the bottom of this tank. Finally got it down good enough to where it's not going to hit this, you know, as I put it back in. And it should last a little while longer. But it's basically just a screw in. So you just take the new element, stick it all the way in, get it started. And with the element wrench, doesn't need to be super tight. Obviously, that's the problem I just had getting the thing out, the old one out. So I'll just go ahead and snug it up in there. Let's see. Try to line it up to, because this wire is short. I'm going to try to get it to where there, I can hook that wire to the top right there, and then this one will go on the bottom. When you put these things in, as far as turning them to lining up your terminals for the wires, it doesn't matter which one goes to which. They work the same both ways. You just line it up to where you can get your wires on there. All right. So I'll take the wire here, put a little hook in it, a little bend, just like wiring an outlet or something. Stick it in there. Try to get it behind the screw, that way when I tighten it up, it'll make contact. Okay, and I'll do the red wire. So you want to bend it and put it on the left side of the screw, or how, it depends on how you're looking at it. You want it to be on the side of the screw where you're tightening from. So if I put it on the left, you know, righty-tighty, so as I turn to the right, it'll pull it in. If I start from over here and bring it in, when I go to tighten the screw, it's going to kind of almost undo itself. So this wire quite doesn't have enough reach on it. So I'm going to pull the screw out completely. Hold the wire in place. And then try to put the screw in. Hard to do from this angle. All right, and then we will put the plastic cover back on here. Bring the insulation back down, cover it up, and we'll put the bottom cover back on. And now for the top here, the top element, I went ahead and put the old one back in because there was nothing wrong with it. I did buy an extra one that I will hold on to in case this one goes bad, but it's not too big of a deal for me to drain the water down a little bit and swap them out. So whenever you turn the water back on. You want to let it fill up at least over top of the top element here, water level, before you turn the power on and these elements start heating up. You want them to be underwater. So as we turn the water back on and it fills up, it's going to build back pressure in here. So we need to let the air escape. So what I do is I keep this top plug open while it's filling up with water. Turn the water on slowly. Keep an eye on it. Let most of the water escape out of the top here. Once it gets right near the top, I shut the water off and then put the cap on it. All right, so hopefully you can see it there coming up to the top, and you have to be real slow about it. I put my pinky in the hole and hold it in there until the tip of my finger gets wet, and I shut the water off. It'll come up out of here like a geyser if you leave it on full blast. So we're just barely gonna crack it open a little bit and let it fill up to the right to the top right there, so we can put the cap on. There it is. Shut it off. Try to get all the air out of the tank. Just go ahead and put the cap back on it. Just snug it up a little bit. It's not going anywhere. And now I can turn the power back on. Circuit back on. Okay, and you should be able to hear it starting to heat up in the tank. You can see where I ran the water out before. And I've got it turned back on. It's nice and clear now. I got it all cleaned out. Full of water, air's purged. Turn the breaker back on. Should be good to go. Thanks for watching.